Okay folks, here's what I've done. I've gone ahead and pulled 200 watts off of the roof and connected it to the cooler. And I have a parallel connector down there to gang these two guys up into parallel. And then the extension cord, and I've got that run inside here to the side of the cooler where it's plugged in. And I'm back here in the back of the shop. So what I'm going to do is I'm going to roll this down so we can take a look at the display on this guy and see what's going on inside without this atrocious glare that's off on the side where you can't see anything. Okay, taking a look inside here, we've got two 12-volt batteries in parallel. These are just quick plug-and-play connectors to hook these guys in. This will provide you a few hours of runtime after the sun goes down, depending on your speed setting. And over here we've got the integrated charge controller. Now, this battery setup is actually integrated into the cooler. We do have a variety where you just have a bypass and the battery connection is right here. It's a pair of MC4 connectors that you can just plug your battery pack into. So if you got a 100 Ah battery that you want to put on this and maybe you don't want to have the integrated pack like this, it's just a direct bypass. Okay, taking a look, we got 3 speeds to choose from: low, medium, high. So what I'm going to do is I'm going to go ahead and turn this on. That's going to engage the pump, which is a 1/2 amp draw. Okay, so if you look at the screen here, we're drawing in a little more current, but we're only using 1/2 amp. So I'm going to go ahead and just run through the speed settings. The first one is low. This is going to give you the longest runtime on the battery because it has the lowest amp draw. So taking a look at where we settle out here, fully running on low, we're about 3 amps. We're supplying 4.5 off of the array, which means we're running fully on solar at this point. Okay, I'm going to click this over to medium. Medium setting. Okay, 3.7 amps. Drawing in 6 off of the array. Now that array has a potential of supplying 10. So we're not really using all the power that's available on those panels. And then we're going to click over to high. Running on high, we're averaging about 5 amps, 5.5 amps. It's technically 5.2, but you know, with brushless motors, there's some efficiency considerations. 5, 4.8, 4.9, 5 amps. Okay, obviously with this higher amp draw, this battery pack is not going to run this system as long. So if you have it on the low speed setting, you're going to get quite a bit longer runtime than you would have on the high speed. Here in Arizona, it's very common for it to be 115 degrees. And, you know, this high-speed setting is great in the daytime because you got a strong wind. So what I'm going to do, take a look in here, you can just kind of see. Okay, taking a look down inside here, the water is going down the media. It's getting it wet. Going all the way across. This has been running for just a couple of minutes. It does take some time for this to fully get soaked all the way across. And the air passing through there is being cooled through the process of evaporation. Okay, I've gone ahead and filled this with water. The water connection is over here, this brass connection on the side of the cooler. Pretty standard for a swamp cooler. This is a standardized body and standardized float valve operation, and what this guy does is this will rock up and down based on the water level, and as it rocks up it will close and maintain the pan full. The pump is over here in this little kind of dark circle here. Let me see if I can focus that. Yeah, maybe not. There's a DC pump in there, and what it does is it pumps water up this tube, which goes into this high density evaporation media, which I spent some time in the lab doing some testing. This is the coldest out of all the medias, and the water runs down this. There's vents on the side of the cooler, so the air is going to get sucked through this, and through the process of evaporation, this media is going to get cold, and it's going to cool the air as it passes through. And that would be the fan drawing the air out of this area. Okay. And then it's going to exit over here, and what you would do is you would have this either patch through your wall on a greenhouse or a structure, you know, where it's permanently fixed. This is kind of a big unit, and that ding in there, by the way, happened during prototyping. I hate to say it, but it just went on. So this was just a demonstration unit. We have these available. We're going to be running these in production this year. And the next stop is we're going to go ahead and throw the cover back on here, and we're going to turn this on. You're going to see it in operation. I've gone ahead and spun it around, and I'm going to drop down in front of here and get some wind ratings. I've got this device here, and what it's going to do is it's going to spin up, and then on this display it's going to give us the velocity of the air coming out. Okay folks, I'm about a foot back from the front of the fan. This is the reading, 905 feet per minute on high. We're going to move off to the side here. Now we're on the side. 1,000, 980. Up here at the top, dead center. Looks like we're getting about 750 on that one. Okay, off to the side here. Up to 850. 136. Okay, I'm going to just step back a little bit here. I'm going to be, I don't have a tape measure in front of me, but this is approximately 6 feet back. Okay, I'm on sort of the lower center. It's about 500 CFM, or excuse me, 500 feet per minute. Feet per minute. This is top center. I don't know if you can see that. It's kind of hard to focus in on it. About 700. Off to the side here. About 600. Okay. So, the point of that reading is when you consider I am this far back, okay, it's a distance, I'm 6 feet back from the cooler, there's a very high velocity, the air is being ejected out of the cooler at a high rate of speed. And this is important because this has to do with a couple of things. Number one, the air is not going to pool right here in front of the cooler and not really travel anywhere. And if you're using one of these coolers, you know, this is a fixed mount unit, so you're supposed to have this guy, this being the side, this being the back. Okay, the cover would be on there obviously. This being the front, this is actually going to be where you're going to enter the wall, is right here. This little outcropping here for the fan. So you do a transition through the wall, ducting this through the wall or a window into your structure, and then on the opposite end of your structure you're going to have a small opening to just let the air flow through and vent out. And it's going to push the air through your area to actually cool it, which is a standard evaporative cooler operation. Now, portable units will be on wheels, kind of like how I have this for display, and they'll recirculate the air kind of like how this is right now being run indoors. But when it comes to cooling, to get the best cooling effect, you want to have this where the intake vents here are on the outside of your building, exhausting the air into your building or blowing the air into your building, depending on how you look at this, and not recirculating the air, because you're getting one pass of the air through the evaporation process, and when you recirculate that, you're constantly adding humidity, which reduces how cool the air actually feels, and it actually reduces the cooling effect overall. So that's a quick demo of the Zendo Cooler, available with integrated battery or connectable 12-volt battery pack. Can handle 600 watts. We've only got 2 plugged in. It can handle 100 AH battery, which gives you a full overnight runtime on high. And it's available as mentioned on the website. I gotta say, this thing really was revolutionary in terms of prototyping and what the testing on the prototype actually accomplished, because this back area of the shop will routinely hover at about 114 to 118 degrees depending on the summer, because we've got west facing metal roll up. It's literally an oven. And this past summer with the prototype in testing, did an excellent job. It keeps things really nicely cool. In a greenhouse structure, you're probably going to have a similar heat load to what we've got in this garage. And as far as residential living, boy, I tell you what, without all the heat load, because you're in a house where you've got some insulation, this thing will really get it. Well worth the money. Available as mentioned.